Alright, I wanted to show the battery voltage challenge that I had to overcome, the battery voltage measurement challenge. So when I first got my controller all soldered together in the box built and I hooked everything up and was testing things more thoroughly, I discovered this issue where if my input battery voltage was under a certain level, the voltage that I was reading on the controller was inaccurate. And I found that when the voltage got to 3.65 volts, that's where this thing would start becoming inaccurate. And the lower this voltage went, the voltage that this showed was just the same. It wouldn't drop down anymore. So it hit a wall. And so what happened is when the voltage got below 3.65 volts on the Arduino Pro Mini power circuitry here, what happened was it went through the voltage from the battery went through a diode, and that caused a little bit of a voltage drop. And then it went into the 3.3 volt regulator that's on the board, and that caused a little bit of a voltage drop. And at 3.65 volts, you actually get the voltage regulator is able to supply about, it's 3.3 volts that it's supposed to output. But and then when the battery is above 3.65, it's fine. The voltage regulator can provide that 3.3 volts like it's supposed to. But below this, the voltage regulator is not providing 3.3 volts. And my calculation for determining the battery voltage had the 3.3 listed in it. So the calculation was the battery voltage is equal to whatever the analog to digital converter value is divided by 1023 multiplied by my voltage reference, which I was assuming was 3.3 volts all the time, times my voltage divider adjustment. And so here's just where the numbers come from. The ADC can read between 0 and 1023, and that represents 0 to 3.3 volts. And then on the circuit inside of the controller, I've got the 10 mega ohm voltage divider. So if the battery is at 4.2 volts, it'll cut it in half, and it will show 2.1 volts. That fits within the 0 to 3 range, and all is well and good. And so when the battery is fully charged, the ADC reading should be about 651. So anyways, this didn't work as the voltage got lower. And what I found online as a solution was, there's a bunch of websites that talk about it, but this one in particular, this provideyourOwn.com, they have a little bit of a discussion of the Arduino's secret voltmeter feature that other people have talked about, and he linked to the other posts about it. But he talked about a little bit further and how you can calibrate the internal 1.1 volt reference that the ATmega chip has got, and create a very accurate reading of your actual VCC level. So you can actually determine, I should kind of step back a second, you can determine the VCC level of your ATmega chip by using this internal 1.1 volt reference that the ATmega chip has got inside of it. There's I got the data sheet for the ATmega chip here, and so there's this input selection channel thing where you can say, yeah, I'd like you to read the voltage that's on ADC 0 through 8. So these are like the pins, like when you do an analog read. This is selecting which one of these to read the voltage from. But you can see way down here, you can actually tell it, hey, take a reading of the 1.1 volt internal voltage reference that the ATmega chip's got built into it. And this should be 1.1 volts because that's what this reference is set to be. And with that, you can use the formula to figure out, well, what is the actual VCC level? And and so this explanation here was pretty good and made me understand it finally. It took me a while. He made me understand it, and then he talked about how to improve the accuracy of it, because the internal 1.1 volt reference isn't perfect. It's off by as much as 10%, so you do have to calibrate it, because it might not be 1.1 volts, it might be 1.05 volts, for example. It can be off by as much as 10%, they say. So, anyways, this article was a big help, and what I did was I modified my software to instead calculate the actual reference voltage. So it won't be 3.3, it'll be 3.1 or 3.2, and that actually fixes this problem. So if I come over here to the my program here, and I'll comment out the fix, or I'll comment out the part that doesn't work, the calculation that I've got here that assumes 3.3 volts, and I instead use a variable that I determine what VCC actually is, using the logic and formulas that I found online. You'll see that when this finishes uploading, it'll actually show an accurate voltage here. Alright, so it's done now. So when I wake this up here, okay, it's so low that my little warning thing is up. Let me turn it up a little bit. I'll just flip it off and flip it back on real quick here. And alright, so now it's very accurate. It's a lot closer. It's not sitting there at 3.7 volts where it was before. And as I turn up the voltage, you can see it stays, pretty stinking close to what it's supposed to be. It's about to power itself off. And so what it's doing now is it's calculating the actual VCC level first, and then determining the battery voltage based upon whatever the VCC level is that it calculated. The little kind of neat thing that I did in my program here, that I won't be able to show all this in detail, but I've got the software available for download, was I made it so that I've got a function here to get the internal reference voltage, which is the 1.1 volts. This, like I said, can be off by as much as 10%. And what I did was I kind of automatically calculate what this is one time. So what I do in the software is I take just a reading of the battery voltage, assuming 3.3 volts, which might be wrong. And if that voltage of the battery is over 4 volts, I can be pretty much assured that the voltage regulator that's on the Arduino Pro Mini is providing, it's 3.3 volts. Now it's not perfect either, but it's more accurate than the internal references. So I'll just assume that I'm getting exactly 3.3 volts when the battery is over 4 volts using this real, unadjusted formula. And then what I do is I measure the internal reference voltage, and it might, in my case for this controller I've got, the chip that I've got in this controller, this measurement that I got from the code on this website here, this measurement is saying that the voltage is 1.083, and I determine that the actual 1.1 reference, and it's 1.083, and then I store that in my EEPROM inside the chip. I store that one time, and what I do is whenever I call this function to get the internal reference, if I've already got that in EEPROM, I just return it, and then if I don't, then I go and look to see if the battery voltage is over 4, and then I do that calculation. I assume from the very beginning that it's 1.1 volts, so if those conditions aren't met, I just return the 1.1 volts. That's as good as I can do. But at some point during the controller's life, it should have a battery voltage over 4 because it charges up to 4.2 volts. And then this calculation will happen. It'll kind of self-calibrate. You don't have to have a voltmeter and calibrate it yourself. And it'll be as accurate as the that 3.3 volt regulator is that's on the Arduino Pro Mini, which is more accurate than just assuming that the internal voltage reference is 1.1. So that was the kind of cool part to this, was the kind of the auto calibration of the 1.1 internal reference. And then so I use that internal VREF in this function, my get battery voltage function. I call that and get the internal one, and then I use that same approach of reading the actual VCC level, and then I use the actual VCC level when I determine what the battery voltage is. And that was the solution to that problem, and it now is accurate, and I can put in to my program good thresholds. I got them up here. So for the battery, so if the battery is below 3.5 volts, and it's pretty stinking close to 3.5 volts, it reads, I show that warning message. And then when it gets below 3.3 volts, that's the minimum voltage. I won't let the user do anything at all. I'll just show you got to recharge the battery at that point. So that's how I was able to get it accurate enough, and how I use this the secret voltmeter and calibrating the internal 1.1 voltage reference to get the accuracy that I needed.